Hello everyone, and first of all may I say thank you all so much for your amazing support. If you would like to see how Cosworth in the UK make a V12 hypercar engine, you have come to the right place. Welcome to part 2, the tour of Cosworth with Chris Willoughby, and of course welcome to the AutoLife.
Okay, so Chris, what area is this? This looks like the fun part.
Yeah, lots of fun happens here. This is the test cells. So we've got 7 test cells in the original bit of the building. We've got 3 test cells down the other end of the road. But I think the really interesting thing about these 3 test cells here, test cells 1 to 3, these were the original test beds that we had and developed the DFV on. If we've got a picture down here.
Good morning.
So the picture up there, we should get a better picture. The picture up there with Mike Heath crowding around the engine. So I'm not sure which of the 3 test beds that photograph was taken on, but it was one of these test beds here.
Wow, that's beautiful to see. Thank you for showing.
And it's still the same sort of fabric. There's a load of stuff.
That's okay. We love this. We love this a lot.
Are we filming there, Chris? Do we need more?
No, I think only because the engine's a bit messy, really. It's got a lot of instrumentation on, so it's not. It looks a bit used.
Give us that pressure so we get continual pressure. So at the moment, that is basically coming from that. But I get why, because the outlet valve
So
backfeeding through the system.
So we run every engine that we make, even the production engines, we run them on the test beds here. We, production engine, we'll do a run-in cycle which lasts for about a day, and then power curve every engine, just as a final quality check. But yeah, so that's a Gordon Murray engine on the test bed. I mean, you just get a sense of the complexity of it when you see all of the systems that are plugged into the engine. They're all doing something, and the flows have got to be right, the temperatures have got to be right, everything's got to be right for the engine to work. We'll go in a bed that doesn't have so we'll the new test beds down the other end of the road are sort of a bit more photogenic, but
this is photogenic, and it smells beautiful.
Well,
I love the smell.
I like these test beds because you're sort of it's less sanitized, and it's sort of
real.
Yeah, you see everything. You see the instrumentation and the complexity of everything. But even, I mean, back in the racing days, even the test beds we had to develop because a normal test bed couldn't run to the speeds that we wanted to run to, so we had to modify the test beds to do that. Looks like we're setting up to calibrate the test bed here. We can supply the engine with fresh combustion air that we measure. We are measuring the air that's going into the engine is an important part. If you're making a development change where you're looking for more performance, you're looking for that airflow to go up.
And Chris, could I just ask, would you be better off using air from Australia?
Australian air is much better, yeah. I think we should have all of our test beds in Australia.
Well, I can possibly organise that for you if you'd like. Thank you.
But yeah, there's a lot of time spent in the test beds. The test beds, when you're running really high-speed, high-performance engines, you can break the test bed as frequently as you can break the engine. So So again, it's an area where we've got lots of experience and know-how how to run a test environment that's reliable. I worked on the test beds originally, and it was a sort of interesting era because engines did break a lot back then, and you'd be trying to piece together these sort of almost like aluminium porridge pile that you had left of the engine, trying to work out what bit broke first.
And at your home in the UK, do you have an engine dyno inside the house?
Well, do you know, my late night, if I'm up too late and have a glass of wine on eBay, I do look for dynos. I do.
Do you really?
If one comes up cheap, I'm gonna buy a dyno, and I don't know what
I would
I'll do with
suggest that's a great idea.
I think
we all
great.
should have one.
They're great
Seriously.
things. They're great things.
Thank you for showing us in here. It's amazing.
Yeah.
Very lucky we are to be allowed in here.
Yeah, we just walk through and see what's on there'll be other test beds that will be a bit more accessible, but yeah, we've got lots of GMA engines on at the moment. Right, let's go through to the main workshop.
Thank you for allowing us to view, Chris. It's amazing.
That's all right. I mean, we're sort of walking. There's lots of like little side rooms and things where we do crack testing and cleaning and evaluation and that sort of thing. And like every step is important to get right.
Oh my gosh.
So just casually, it's a Bugatti engine, new Bugatti engine on there.
Just casually, it's a Bugatti engine.
We can't go into too much detail on that one, so we just need to pass over it.
So we've got...
Chris, is there anything that we can't film?
Is it okay to film in here?
Probably not the Red Bull engine, which is sort of those benches over there.
Yeah.
But I can tell you sort of generally about the workshop. So we have two engine build workshops here. One workshop builds the sort of prototype and one-off development type things. But the focus of this workshop here is to build the production engines, and there's a slightly different approach between the two workshops. So everything in here is really tightly process controlled. You can see we've got PC monitors on every bench, and we still have a really manual build process, but it's really important that everything is built to the build manual, in the right way. Even though it's almost more important in some ways because the engines are so high performance and the safety factors are so low in the engines. If they're not built correctly, you will end up with a problem. And so, I mean, we'll sort of walk round over here and see what we can.
Oh my God.
So I'll point some bits out as we walk around. So that's pretty typical for one of our crankshafts. We make those in house. We start with a billet of steel. We don't forge the crankshafts at all. It's probably the longest lead time item on the engine, but there'll be. I was sort of talking about materials earlier, and things like the cleanliness of the crank steel is really important. If you get a tiny bit of dirt in the crank, under one of these radiuses that are really high stressed, you get a tiny inclusion of dirt in there, and it might only be the only bit of dirt in the crank, but if it's there, the stresses are so high that'll initiate a crack, and the crank will unzip from that.
Which equals sadness.
Yeah, lots of sadness, and that if a crank fails, it'll take the rest of the engine with it. Yeah. So we get a very, very clean steel made for us.
Special steel for Cosworth.
Yes.
Yeah.
Yeah.
Yep.
Yeah. It's in many ways it's a sort of wider standard, but it's the cleanliness that makes it sort of specific to us. So, and even things we have to get gears ground on, and so there's lots of processes. There's lots of heat treatment as you go through the process. So, yeah, well.
Wow.
So a big part of.
Is it okay to film this?
Yeah, I think that's fine. That's but maybe not the pistons actually.
Okay.
This is relatively standard Valkyrie. They're race pistons.
Is it okay here?
Yeah, I think that's fine. So when we run an engine, a really important part of the process is not just whether it survives or not. We take the engine apart. We look at everything we can in real detail. We're looking for small signs of wear. We're looking for obviously things like cracks. You wouldn't expect to see any cracks in an engine that has done a durability test. And so, I mean, we can work the engines on the dyno here much harder than they get worked in a car. So whether it's a race engine or a production engine, we'll always, we'll have a clear understanding what the life of the engine is, and then we'll test it beyond that to make sure that we're safe.
So with the hypercars that you're currently building amazing engines for, do they have a life? Do they at, 50,000 Ks, do they need to come out, be pulled down, non-destructive testing, or?
Yeah, it's of that order. It's a bit higher than that in slightly different project to project, but we supply the engines with a warranty. So if they go wrong...
Okay, Cosworth supplied for those? Wow.
It's our problem. And so we typically do, probably the hardest test for an engine, we'll do what we call a high-speed durability test.
Yeah.
And that is near peak torque and peak power for about 100 hours. We kind of give it a breather and it comes down, then it goes up again. And that, in terms of testing the main sort of structural elements of the engine, that's the one that's probably the biggest challenge. But we know if an engine goes out the door and it's passed those tests, and we typically do 2, maybe 3 of those tests for every engine that we design. So you haven't just got a statistical fluke that you got lucky with one engine.
Yeah, it's tried and tested.
Yeah, and
signed off.
So, but part of that is pulling the engine apart, inspecting it in detail, crack testing everything, capturing all of that information. And we'll durability test at different stages in the program. So we'll do an early durability test that can feed back into the engineering program, and we can make changes if we need to.
And you have your own carbon composite section?
No, we work with some local companies.
Okay,
We've got some
okay.
really good composite suppliers locally.
Is it okay to film here? Or?
Yeah. This is fine. You can look at.
Wow.
So
this is just like art.
and these aren't especially shiny or anything. This is the way they are
I
in
think
production.
they're beautiful. My gosh.
But we were talking about running to higher speed earlier, and these are the cams. They're gear driven. These are some of the gears that drive from the crankshaft up to the camshaft. Really, the high speed engines, chains won't really survive.
So you have to run gear.
So we have to run gears. But the problem you have at really high speed is that everything acts like a piece of elastic. Really, every material will do, and the cams are no different. And when you're running at high speed, you run through a resonant frequency, and which means it twists from end to end. The camshaft twists a lot, and so these discs down the end here, these are dampers. So the drive gear's down here, and so without those dampers, the cam would be free to sort of twist and get into a natural frequency, which would then break the camshaft. So having those dampers, and we tune those, we do all of that in analysis, and that's, you know, where the science gets fairly heavy, predicting what damping characteristics that damper has to have to tune out the frequency at the right engine speed. That's something we simulate, and because we've done a lot of it, you know, we validated the simulation. When you do any simulation, it's a really important part of the process is to then go and measure what you've done in reality and feed that back into the model and adjust the model to reflect reality again. And every time you revalidate the simulation models, they get better and better and better. And because we've done that lots of times now, I mean, this sort of technology was developed when we first went to 20,000 RPM on the Formula One engines. So, you know, it's still, you know, lots of racing technology in our engines.
This is just, thank you so much for allowing us to see this.
That's quite all right.
It's amazing.
It's sort of popped up what. Can we get that open? We'll find some other bits as we go round. Morning, sorry, can we be nosy?
Can I film here or not?
I think it's okay here. This is where we're building engines for Gordon Murray. So with the Gordon Murray project now, we're well into the drumbeat of making production engines. We make a couple of engines a week, typically. I mean, most of our customers want a similar sort of cadence with their projects. So, you know, whether it's Valkyrie or Gordon Murray or Bugatti, and that to us, that feels about right. You know, it gives them 100 vehicles a year, which is about right for the market. But it's quite it's surprising, you know. Kind of we sort of built up a buffer stock initially to make sure we could supply reliably, and you end up with quite a lot of engines sitting around, and it looked fantastic. This whole floor area had engines on it one Christmas Eve, and it was a really good way to finish the year.
Could I ask, all the engines that get built, do they have a name? Do you name them?
We number them.
You number them. Okay.
Well, I mean, from the legal perspective, production engines have to have a number.
Beautiful. The assembly of art. Yes.
Yeah, and we,
The assembly of art.
I'd say it's a very controlled process, but it's still a very manual process, and actually it's a challenge to get people that have these skills. You know, kind of it's not. They're hard to find. It's having the sort of diligence and attention to detail.
Has
and,
to be.
You know, it's our last line
Perfect.
of quality control.
Has to be perfect.
You know, if the engine builder picks up something that's not quite right, they need to be able to see it, and we need to catch it before it goes out the door. So say this is the production engine workshop, and which for us is sort of, you know, our where we're getting to, where we've got to in lots of ways. You know, we've now got a portfolio of engines that are in production, and there's a regular drumbeat to their production. We've got the machines busy in house now, and so it's interesting. You know, we kind of went from that post-race period to now, and yeah, we tried lots of things in that time frame. But this is a really natural fit to everyone in the business. You know, we're
Absolutely perfect, isn't it?
You know, it feels.
Thank you for showing us.
It's sort of, the place has got a buzz about it that's similar to the sort of early 90s.
Yeah, I'm sure.
Great.
Which is great. Yeah?
It's got a really good feel to it.
Amazing.
Right, we'll carry on walking.
Okay, to film.
Yeah.
You're doing a beautiful job.
Thank you.
It's a piece of art. My God, can I film this?
Yeah, this is Gordon Murray production engine about to go out the door.
Wow. Wow.
So we'll have dyno test this. We'll have power tested it. We'll have run it in. You know, we measure a lot of parameters on the engine on the dyno before it goes out the door. You know, to make sure that it's exactly as it should be. But this was a really good example. We were talking earlier about the sort of working with the customers conceptually. You know, Gordon had a really strong vision about the capacity of the engine and what he wanted to be unique about the engine, and he's obviously didn't want to join the power sort of arms race of just raw power numbers. You know, he wanted to produce a light, agile vehicle with a light, agile engine, and so sort of taking those things at the concept stage and working it through to this, you know, is you know, and you know, Gordon knows a surprising amount about engines.
He does, yeah.
You know, so he was really involved in that process.
I think this is the most beautiful thing I've ever seen. It's seriously like art, yeah?
Yeah.
The finish, I'm sure the materials used.
I think we think
You should
so.
be
I think
proud of yourself.
One of the
yeah?
things that the interest in the hypercar engines has sort of it's brought a lot of interest into the engineering side, and I think one of the things we're keen to, you know, we want this to sort of inspire the next generation of engineers, you know, because it is, you know, engineering is an interesting field.
Do you think I'd be allowed to come back here and do my apprenticeship again at 64?
Well,
or not?
If you catch us at one of the moments when we need some engine builders, then
Righto. I'll leave my phone number if I could.
Okay,
Thank you.
Right, so we move on.
Right, yeah, let's carry on walking. We overreacted to how small the test beds were down the other end of the road. So when we built these test beds, we wanted to make sure there was absolutely no question they were big enough. And so we've got three test beds in this building that are broadly similar, other than the test bed in this cell. We can run a transmission on there, these blue absorbers off the side, so we can run drive shafts from the transmission into the gearbox. That allows us to run the engine and the gearbox together, which when it's an automated gearbox, whether it's a race gearbox or a road gearbox, there's lots of communication between the engine management system and the transmission management system. So we can get all of that resolved here before you then drop that really complex engine and transmission thing into the really complex car. I mean, a lot of the challenges now around electronic control systems, particularly when they're road cars and they've got you know, lots of things like ABS and vehicle security and immobilisation, all those sorts of things. All of these computers have to talk to each other, get along with each other, do the right things when they all expect it to. And so getting that engine and transmission subsystem working in this sort of environment well before it gets into a car is really useful. These test beds are fully transient. We developed them originally for Formula One transient testing, so we can simulate a Formula One gear shift, which is a very quick gear shift event here. We can control even things like humidity running into the engine. Humidity can have a bit of an effect on engine performance, and so when you're looking for really small, you know, if you're looking for 0.25% of performance change, you need a really accurate test environment to see that. Even then, sometimes you have to go back and repeat the baseline, repeat the development step, and so controlling the temperature of the air, the humidity of the air going into an engine is an important part of that experimental accuracy. Because sometimes if we make a big change to the engine, so we change something on the cylinder head, the engine comes off the test bed, goes to the workshop, comes back a week later, and you might find that ambient temperatures changed by,
Yes.
well, like on Saturday, you know, the ambient temperature changed
Sure.
a lot in one day.
And with the hypercar engines that you're doing, do you supply the engine management control system for all of those?
On the Gordon Murray project we do.
Yeah.
That's the only project at the moment where we do that. But we ended up developing that engine controller really just to give our customers a choice. And so it's such an important part of the engine. If you don't have it, the project can't move forward. So
yes.
it's really important for us to say, yeah, we have an engine management system that works, and we'll take you to an emissions standard, and and things like the Gordon Murray vehicle. You know, one of the things we're most proud of actually with the reviews we get off of the engine in that vehicle. People are really surprised how pleasant the engine is to drive. You know, you can go shopping with it, and then take the engine speed up, and it feels like a race engine, but round town it drives, and that's all part of the engine management system and the calibration that you have to do. I mean, the calibration part of the project is with the dyno work and the in-vehicle work that can easily be 18 months or 2 years. So that's a big part of a road car program these days. But this sort of environment is where it all
it's
starts.
Amazing.
Yeah, we can do
Thank
transit.
you for showing us.
We can do a lot of things in this test environment. Doesn't sound like anything is running, unfortunately.
That's
so
okay.
You're not going to have the pleasure of.
It's all good.
So we set this facility up in 2015, and originally it was a sort of slightly separate bit of the company that was really focused on making cylinder heads and cylinder blocks for customers, but to the customer's design.
Yeah.
So, but over the course of time, with our own projects, you know, we're slowly sort of migrating over from making parts for other people to making our own engines in here. So the example of a project that we did in here, this is the Honda NSX, the latest Honda NSX. So
really? You do that?
Yeah, so all those components you can see there, we machine.
Wow.
Which, I mean, that was, it was, in terms of learning about production, that was a really good project because you work for a customer like Honda. And, you know, even though the vehicle's not their typical sort of volume, you still have to make it to their global quality standards. There's no concession. And so going from a company that machined its own race engines where, you know, kind of if something's not quite right on a race engine cylinder head, for example, you can go and find the engineer, get a concession raised, and it's good, you can use the part. If you're making parts for Honda, they are just not interested in any sort of concession.
No,
so it's either right or it goes in the bin.
Yeah.
And so you learn a lot about process control, you know, even how you handle the parts and not damaging critical surfaces and things like that. So for us, some of these OAE projects that we've done here have been really good, and it's that sort of invisible bit of the learning. You know, I think people look at the engines that we make in terms of their specification, and they can see that, you know, they're pushing the boundary. You know, we've had to making those things as well is a really big part of the equation. And you know, if you're going to design something with a really low safety factor, it means you need really, really good process control to make those parts. So it goes very much hand in hand with the design of it. But you'll see what I mean when we go up and have a look at it from the top. It's a bit noisy when we get in here, but
That's okay. Noise is good. Thank you.
So the way the factory's laid out, there's the central grey spine that runs down the middle, and essentially that's a distribution system. So we load the castings in to that system just down here where you see those roller shutter doors, and then that system will take it to the right machine. We've got 2 robots. So that's that robot that's moving over there. That is to take the right tool to the right machine.
Wow.
We can store tools on the machine, but you need so many tools to machine something like a cylinder block. We have these robots feeding, taking and returning tools to and from the machine.
Very clever robots.
Yeah, I mean, it's kind of we run this facility 24 hours a day, 5 days a week. We did run it 7 days a week, but you've got nowhere to go if you need to catch up. So 5 days a week, it gives you a bit of breathing room. And so for us, I mean, this is the facility where across all of our programs, our heads, blocks, you see things like Valkyrie cam covers down there, Bugatti cam covers. So anything that's big, essentially we've got big machines here. So machining sort of large aluminium components is what happens here.
And you have your own foundry to make all these?
We used to have our own foundry.
Yep.
But now we use European foundries, so a combination of UK and European foundries.
Okay.
It's still pretty hard to get a good quality aluminium casting.
Is it?
Yeah, it's inherently, because it oxidizes so quickly, it inherently, the oxide's not what you don't want mixed in with the aluminium when you pour it. And so it's inherently really difficult to do a good casting. And that's originally why we started our own foundry, was to get better quality castings. But now we sold that and we now use external foundries. This is a new bit of Cosworth that's absolutely integral to us delivering production programs to customers.
It's incredible.
We'll walk down because there's some bits down the other end that so that noise you can hear that sounds like someone pressure washing something.
Yeah.
It is exactly that in that ABB machine. So there's the robot outside. What we have in there is a really high pressure lance, and what that allows us to do, there's a robot inside there, and the robot can articulate the casting. So when you machine the casting, there's things like swarfing oil galleries are an absolute disaster for an engine. And that lance means we can get right up all the galleries and give them.
So it's perfectly clean.
It's perfectly clean. I mean, it's so high pressure. Theoretically, we could deburr with it. We don't use it for deburring, but we could do. If it opens in a minute, you'll see the.
And it's a robot in there, obviously.
Yeah. So the high pressure lance is static, and the robot moves the component around to. And so for us to make a component in here, there's quite a lot of machine programming to be done, so that takes quite a long time. But it fits in with our sort of, we're about 3.5 to 4 years to go from clean sheet to first customer sale. On all of these, programming all of this, getting all of our processes laid out in here are a really important part of that journey of putting something into production. And even, we do make some aerospace components in here, so, aerospace, there you can see the robot.
Oh, really? Beautiful. Wow. So that engine block's all clean, all healthy.
Yeah. And because it's automated, we know that every component's clean. I think, a lot of people do a more manual cleaning, with bottle brushes and things like that. We want to be able to sit in front of our customers and say, we know these parts are completely clean. Well, as I say, we have a warranty on pretty much every project. So if there's swarf in an oil gallery, we pay the price. The machines over the back with the 2 red lines around them, I'll show you a picture that explains it a bit more, but our bore coatings, so if you look at that cylinder block down there, you'll see that's just the bare machine casting. So we, rather than having a separate liner, we spray the bore with a really thin iron-based material layer. And we spray it in a plasma, so it sort of fuses to the surface.
So no heavy cast iron liners?
No, it saves a lot of weight. It means you can, it saves a lot of weight in the liners, but it also means you can move the bore centres closer together, which saves more weight.
Yes.
You get really good heat transfer, and when you run the engines, a lot of the science in getting a high-performance engine to run reliably is getting the heat away from all the critical components. So we have this thin-walled iron layer that's fused to the aluminium surface. That means the heat conductivity through that into the aluminium, into the water tap, it's really good. Which you can't get that with it's difficult to get that with a steel lining. But I'll show you in a so this is the parent aluminium of the cylinder block. We machine in this sort of dovetail feature here, which this is the plasma layer here, the darker grey. You can see, not only do you get the kind of plasma bond of spraying a molten metal onto a surface, you also get a mechanical keying in because of the shape of that groove. Now, when you look at that groove, if you actually look at a ball that's been machined, and this is when you get to realise, you need to know what sort of generation you're talking about. It's like an old vinyl record. The texture of it. When you get younger people in here, they don't know what I'm talking about, but
I do.
But that surface there, that
it's like a vinyl with the ripples, with the grooves.
Yeah, just you can feel it with your nail, and you can just sort of bounce it. So it's very sort of almost microscopic machining operation. And then other things, you get these sort of dark areas of porosity. But you can imagine you get these like drops of molten metal hitting the surface, and as they solidify on the surface, you get pockets of just gaps in between. The really good thing with that is it gives you a sort of oil retention on the surface of the liner. So the honing effect, we still hone the balls, but it isn't quite as important for the oil retention. And we use this process on all of our engines. We've used it in racing for decades now. So it's a very difficult process to control, but we've done it for so long. The kind of expertise exists here to do it reliably. So that's a key part, and we invested heavily in putting that plant in here. 2015. So wow, it's nearly, it is 10 years old-ish now, this facility. And I think I think for me, I mean, particularly when you're bringing customers around from a larger automotive background, I think they recognise how much knowledge you need to run a facility like this.
Yeah.
So it's a really good showcase for Cosworth today. And for us, you know, the manufacturing of these engines, it gives us such a sort of stable drumbeat to the business. I think, you know, we went through a period where we were just doing consultancy work, and the consultancy work's sort of like boom and bust. You know, you either have too much or not enough. Whereas having this strong manufacturing drumbeat to the company is important. Is really important.
Yeah. Okay, so Chris, what room is this? We've got a beautiful engine on display, but you wanted to show me this. What's this?
So this is Keith's original drawing board that he designed the DFV on.
Seriously? The real drawing board?
And if you look on the page there's a picture of Keith at this drawing board. And that's how it was done back in the day. You tape a piece of paper to this and just get going. And, you know, it's all just pencil on. We used to draw things on, it's like a plastic film rather than just plain paper. But that's all you had. That and a set of set squares and, you know, compasses and that sort of thing. And the complexity of an engine was just created in 2D.
Amazing.
With those sort of limited tools. It's mind-blowing now to think that that's how it is.
Thank you so much for showing us all this beautiful piece of history, and thank you for the amazing tour that you've done for all of us, and you are a big part of the AutoLife. Thank you so much.
Thanks very much, it's a pleasure.